Hi everyone, this is going to be your pre-lab lecture for Lab 10, Sn1 and Sn2 reaction. Lab 10 is the last lab, so congratulations. You've made it this far. This is an online lab for all three groups, Group A, B, and C. Group C will be doing this online the week of November 9th through November 13th. Group B will be doing at the same time as Group C, and then Group A will be doing this lab the week of November 16th through November 20th. Okay, so make sure, like always, read your lab manual, turn in your pre-lab quiz, make sure you watch these videos. Make sure that you turn in your notebook on Sunday before 11:59 and that you are using the data provided. Okay, so Sn1 and Sn2 reactions. This is a two-part lab. We have the Sn1 section and the Sn2 section. So make sure you do both sections. Don't just do one section. Acid catalyzed substitution reactions. Alkyl halides can be prepared from their corresponding alcohols via acid catalyzed substitution reactions. The mechanism of acid catalyzed substitution reactions are labeled as Sn1 and Sn2. I believe a lot of you guys have already gone over Sn1 and Sn2 reactions in class, so this will just be sort of a review. Tertiary alcohols follow the Sn1 route. We will see later on why it's more favored. Actually, I added it in here. Never mind. Sn1 reactions are favored by tertiary alcohols because they tend to form more stable cations. I believe I put the mechanism a little bit more in some other slides ahead. So the mechanism is there, and you will see why the carbocation is so important for Sn1. Primary alcohols follow the Sn2 route, and then secondary can follow either Sn1 or Sn2. Sn1. Under acidic conditions, the Sn1 mechanism involves rapid protonation of the alcohol. As you can see right here, we have an alcohol. So that alcohol would get protonated, and then we would be followed with a loss of water, which is a rate determining step. Afterwards, we will create a relatively stable carbocation, and from that carbocation, it will then be attacked by the halide ion to form the alkyl halide that we can see right here. Right here we have T-butanol, and it gets converted to T-butyl chloride. Sn2. So the mechanism for Sn2 revolves rapid protonation of the alcohol along with a concentrated step where the nucleophile attacks the carbon, displacing water. The backside attack by the nucleophile is favored for primary substrates and less ideal for secondary and tertiary substrates. Synthesis of tert-butyl chloride. This is the first part of lab that I was talking about. So the objectives for this lab are to synthesize tert-butyl chloride via Sn1 reaction. Remember, we're doing this by converting T-butanol to tert-butyl chloride. We're going to confirm the presence of a tertiary alkyl halide using the silver nitrate test. Insoluble silver nitrate halide would form if tert-butyl chloride is present. And then we will verify the product by gas chromatography. Calculations and data. Make sure you include theoretical yield. You should have 6 tables in total. For this section alone, the Sn1 synthesis of tert-butyl chloride, you should have three tables. And then for the second part, which is Sn2, you should have 3 other tables, so in total, 6. For your post-lab questions, Sn1 has 5 questions, so make sure you add those. And then Sn2 has 3 questions, so make sure you add those too. A little reminder about your post-lab questions. They go after your conclusion, not before your conclusion. Please switch that, please. I've been getting a lot of notebooks where their post-lab questions are before your conclusion. It's after your conclusion. For your procedure, you have to write both procedures for Sn1 and for Sn2. Sn2, synthesis of 1-bromobutane. The objectives are to synthesize 1-bromobutane via an Sn2 reaction. Over here, we can see we are converting 1-butanol to 1-bromobutane. We're going to confirm the presence of a primary alkyl halide using the sodium iodide test. Over here, we did the nitrate, sorry. And over here, we're going to be doing the sodium iodide test. If our primary alkyl halide is present, then it will be we will see an insoluble precipitate form. And then we will verify this by the product by gas chromatography. Calculations and data, we need a theoretical yields for both Sn1 and Sn2. And like I said, there's 6 tables in total, 3 for Sn1 and 3 for Sn2. And that is all I have for today. I do want to remind you guys to please turn in the extra credit that was posted by Dr. Stogie if you guys definitely need the points. Also, I will be sending out sort of a poll to see if you guys want me to create a list of topics for you guys to study for the final, and I can post that for you so that you guys have something additional to study for and you're not so lost as to what to study and what not to study. Also, if you guys don't want that and instead you guys want me to just open up some office hours for you to come in, I will be sending a poll to see which one you guys want. And that would be it. So yeah, email me if you guys have any questions.